Dr. Hauk here. We're going to solve this problem, calculating relative abundance. We're going to use the formula that I've already written on the screen here. Atomic mass is equal to the summation of each individual isotope mass times its fractional abundance. And in this question, we're told that vanadium has two naturally occurring isotopes. We're given their masses, and we're asked what is the relative abundance. So we're going to be solving for this fractional abundance piece of the equation. So first, we need to know what is the atomic mass of vanadium. And luckily, that information is found on the periodic table. If you look for that, you'll find the mass is 50.9415 AMU. And we're going to set that equal to the sum of each individual isotope mass. So starting with vanadium 50, that weighs 49.9472 AMU. And we're going to multiply that by its fractional abundance, which we are asked to solve. Let's call that X. So I'm labeling vanadium 50 with an X. We're going to add that to the mass of vanadium 51, 50.9440 AMU, times its fractional abundance, which is unknown as well. And we'll call that Y. So now we look at this and we say, well, we want to solve X and Y, but we have two unknowns in just one equation. How can we do that? Well, you can't. So we're kind of stuck. We have to think, what else do we know about this? And what we know is that the sum of X plus Y must equal 1. Right? All of the fractions must add up to 1. So now we have two equations, two unknowns. We can solve this. So what I need to do is solve this X plus Y equals 1 for either X or Y, and I'll just solve it for X. X is equal to 1 minus Y. So now I can plug this in to my equation. After the substitution, I will have one equation, one unknown, and I can solve for Y. All right, so quickly solving here. We're going to subtract 49.9472 from both sides. And get 0.9943 rather is equal to, we can add these numbers together, the y's, that gets 0.9968 AMU times Y, and solve for Y by dividing by 0.9968. Units will cancel. Y is a unitless number. As a fraction, 0.9975. Or as a percentage, multiply that by 100%. It's 99.75%. This becomes easy to solve because X is equal to 1 minus Y. So 1 minus 0.9975 is equal to 0.0025 or 0.25%. So now we just have to make sure that we assign these percentages to the appropriate isotope. So because vanadium 50, that was corresponding to the letter X, that's 0.25%. And vanadium 51 is equal to 99.75%. We should always check our answer and say to ourselves, does this make sense? Well, if I look at the average atomic mass of 50.9415, that's really close to 51, so I would expect there to be significantly more vanadium-51 than vanadium-50, and that matches what we expect, so we get a check mark for our correct answer. Alright, so hopefully you can follow this format for solving your clicker homework that will be sent out